my guitar introduction as usual. So we're going to go ahead and look at the second part of the video for this section. This is where calculus begins with the idea of a limit. So we're going to start by thinking about what's called Zenos Paradox. It's a paradox that was proposed by Zeno way before calculus began to be developed in the 1600s. And Zeno made an argument that if you're going from one point to another point, that you always have to travel half of that distance. And the idea is if you always cut numbers in half, you should never get to zero. So one way to look at this is like if you're a football fan, say that you're on the 10-yard line, and here's the 10-yard line right here. Here's the goal line right here. So if it's first and goal and then the defense commits a penalty like offsides or something, the referee's going to move it to the 5-yard line. Okay, and then say, for instance, the defense jumps offside again. It's another penalty. The referee says half the distance to the goal. Now we're at the 2.5-yard line. And if we kept doing that over and over again, just halving these distances, in the mathematical realm, you would never hit the goal line. That's kind of the essence of what Zeno's paradox is doing. Here's an illustration on a GeoGebra application, which is kind of just a quick, nice thing to show. So this is basketball. You're going from this end line to this end line. Zeno argues that you're going to go in a certain particular amount of time. You're going to go halfway. Then in another part of time, you're going to go halfway again. So now you've made 75% of your journey. Now you're going to cut this in half. Now you're at 87.5. Then he's going to argue that you have to go halfway again. Now we're at 93.75. So as we continue to go halfway, notice that we're never going to reach the 100% mark of the journey in the mathematical realm. All that's going to happen is this number is going to get closer and closer and closer to 100%. But the idea of a limit is that that's the number that you're approaching. So the limit is the 100%, even though the mathematics is never going to reach 100%. So in calculus, the idea of a limit is real central to everything that we're going to talk about here. Okay, so I'm going to go through and just kind of help develop some ideas using the graphing calculator a little bit to help us. So to begin with, what I want to do is do a graph of the function y equals 3x minus 4. One thing that I would want a student to know from their background is that negative 4 is what we call the y-intercept. And if you're going to graph this line out, you would start by putting a dot right on that point, which is the point 0, negative 4. And then the number in front of the x is called the slope. And since the slope is 3, that's the same thing as 3 over 1. And the slope is a ratio of distances. The top number is telling you what the rise is. The bottom number is telling what the run is. So since both these numbers are positive, that top number is saying rise up, because up is the positive direction. And the bottom number is positive. So that's going to tell you to go in the positive direction, which is to go to the right one. So from this point, what you would do is you would go up 1, 2, 3, and then over 1. That would take you to another point on the line. That's 1, negative 1. And then I could go 1, 2, 3, up and over 1 to get to the point 2, 2. And I'm going to go ahead and just do that one more time. Go up 1, 2, 3 over 1. And that takes you to the point 3, 5. And all of these numbers are solutions to this equation. So notice if you take this 0.35, if you plug in 5 for the y value and you plug in 3 for the x value, you get 5 equals 3 times 3 minus 4, which is true. So when you're graphing any type of a function, really all of the graph of a function is a picture of all the solutions. Sometimes students don't make these connections in earlier classes, so I like to kind of mention those as we go. All right, so we've got our line now. So what I'm going to go ahead and do now is just connect the line, the dots into a straight line. The line's going to go forever in both directions. Then I'm going to get my calculator out and kind of introduce you to the idea. In calculus, the first thing you learn about is the limit. So this is an expression down here is saying LIM is the abbreviation for limit. So we are finding the limit of the function that we just graphed, 3x minus 4, as x gets near or approaches 2. So that's why I'm going to read that as the limit as x approaches 2 of 3x minus 4. Okay, now what this table of values is going to kind of train you to think of the limit in a certain way. So I'm going to go ahead and get my graphing calculator out. And what I'm going to do is just put in this function, 3x minus 4. So I want to press my y equals button. And I just put in the 3x minus 4. So there's 3. You press this variable button, and that x will come out automatically. And then we're subtracting 4. And what I like to do when I do a graph, instead of automatically pressing the graph button, I like to go zoom number 6. That puts you in what we call a standard window. And if I press enter, it's going to graph that. So the standard window is going negative 10 to 10 on both x and y. So if I press my window button now, you're going to see x goes negative 10 to 10, and so does y. So that's a good way to graph, is just go zoom 6, and it'll automatically put that in the standard window. Now, I gave you these values, and there's a couple of ways that you could get these values, and you would be doing this on your homework. One way you could do this without your graphing calculator is you could just go 3 times 1.8 minus 4. Just plug these x values in. I'm going to show you a quicker, more efficient way to do this in just a minute. So I'm going to do 3 times 1.8. And then subtract 4, and the calculator is going to give us the answer that I got, 1.4, like that. And you could do that over and over again for each thing. It would take you a lot of time, though. So a better way to do that with a graphing calculator is to learn to use your trace button. So if I go through right now and type the trace button, then I can enter this value of x. So if I enter 1.9, I'm going to get 1.7. And usually, like on my calculator, I only have to type trace once. I could go ahead now and go to the next one and type in 1.99. There's 1.999 to put too many nines in there. That gives the 1.997. So you could get those values real quickly just by using your graphing calculator to make that go fast for you. So the basic idea when we're talking about a limit is we're looking as x approaches 2. That's why I did not give a function value for 2. I left a question mark on there on purpose. And the basic idea is going to be when you're looking at a limit, you're coming from the 2 from 2 directions. You're kind of coming from underneath the 2. And notice what's happening is these y values appear to be going somewhere. Okay, it looks like they're getting bigger and bigger, but it looks like they're getting close to 2. Okay, then if we come from above the 2, the same kind of thing happens. Notice that these x values are getting closer to 2. 2.2, 2.1, I'm closing in and getting closer to 2. And these y values right here are doing something. They're also approaching a finite value. So these are getting closer and closer to 2 also. So when you're doing a limit, you're actually looking at what is the y value getting close to as you get close to the x value. So you're closing in on x. The idea here, the answer to a limit is a y value, so that's equal to 2. Okay, like that. And what would happen on the graphing calculator, I'll just show this one more time. Like if I take a number just barely under 2, like, even get closer and closer, this time I'll put a whole bunch of 9s in like that. I'm not at 2, but I'm just getting closer and closer to 2. So it's kind of like Zenos Paradox. The answer to a limit is the number that you're getting close to. Think of it as what you're getting close to. All right, so that would be kind of the beginning example to give you an idea of what a limit is. All right, well, and a lot of times students in this problem will say, well, why in the world don't I just take this 2 and plug it in? And I get 3 times 2 minus 4, that's 6 minus 4, get 2. That's my answer. Well, sometimes it works that way. Often it doesn't work that way, though. So we're trying to develop the idea of how, as you close into x, you're closing into some specific y value. Okay, down at the bottom of the page, what I've got is some definitions that you want to be sure that you know. We have three types of limits. We have what we call a left-hand limit, which we'll talk about what that means on the next page. And what that's going to show is like the limit x approaches, and let's say we're approaching 2. If we have that minus sign, that tells me that we're coming from the left side only. We also have what we call a right-hand limit. And the right-hand limit, the notation's a little bit different. It's going to look like this. Say, for instance, you were doing a similar problem, the one I just did. We're approaching 2. If we have that plus superscript, that means the limit is coming from the right-hand side. So those are two types of limits. And the one that I did is what we call a two-sided limit. And in this case, we say x arrow 2, and we don't have that superscript of a minus or a plus. So at the bottom, I just want you to get the idea of what is the notation, how are you going to know if you got a left or right or two-sided limit. That's the idea. Okay, so I'm going to move to page 5 and do another example with the graphing calculator to kind of begin to develop this idea. So we're going to just graph this on the calculator. All these things are going to be done on the calculator. First thing I want to mention on this problem is we have an absolute value. So if you have to graph an absolute value, the keystrokes that you have to have is you have second, then when you press, whoops, I think I got something going on here. So I go second. Oh, no, I'm sorry, I don't do that. First I go math. Okay, so I press the math button. And then I use my right arrow key to move over to NUM. And these is another menu for some numeric values of different types. And then notice that option 1, ABS is standing for absolute value. So that's where you find the absolute value symbol in this then. So I'm going to go to y equals. I'm going to erase what we did in the previous example just by typing clear. And I'm going to put this in. So again, I do this. I go math, a right arrow, number, and then I do the option 1 and just press enter. And then the absolute bars, value bars come out. Then I just put in 2x. You want to get out of that symbol and then divide by x like that. All right, so then we'll graph this in a standard window. So again, I'm going to go zoom number 6. And that puts me in a standard window. Okay. Another thing you want to get real comfortable with in calculus, if you're not already comfortable with it, is you have this table of values. So if you go second table, or second graph actually, it'll open up the table of values. So it goes second graph, and this will give me x values, what the different y values are on here. So notice what's happening on this. It looks like there's one place where there's an error. And the reason there's an error is because if x is 0, you would end up getting something that's undefined. You would get absolute value of 2 times 0 over 0. So you can't divide by 0, right? So it's undefined right there. So you do not have a function value right there. Okay, and the idea, if we go through and graph this, this is how the graph of this function is basically going to look like here, is kind of like this. So I'm going to just take some of these values. So like I've got the point 1, 2 is a point, 2, 2 is a point. So it's pretty clear that you're always going to have a y value of 2 out here. Now, since you're undefined at 0, you're going to put a bubble where that comes to an end, an open bubble, then take that to the right and put that arrow to represent that it goes on forever. Look at the negative numbers, though. They're different. So you have -1, -2, and then you're always going to be -2 for these values here. And again, don't start at -1, start at 0, but represent that with a bubble, because you got to show where that thing comes to an end. All right, because you got all these decimal values between 0 and 1 that you can use. And the table of values on this, you can do the same tracing idea. You could, if you wanted to type trace and then -0.1, well, all it's going to do is give you -2 and so forth. If you traced it -0.01, it's going to keep giving the same thing. So as you close in on 0, you're getting closer to -2. In fact, you are -2. And if you're closing in from 0 from above, you're at 2. So what happens on this limit is the first thing is you have to look at this one says x arrow negative. This one right here is a left-hand limit. We call this a left-hand limit. So what that's going to mean is it's going to mean we're closing in from the left-hand side. So if we're to the left of 0, as we get closer to 0, well, the y values are just reaching -2. So that means the answer to that limit, the left-hand limit's -2. Okay. Then the right-hand limit, which is this next thing because it has the plus sign on it, you've got a right-hand limit, and this just means this. You're coming from above 0, so you're closing in this way, and what's happening on that is something different's happening. These numbers are just always 2. So the answer to that limit would be 2. So you kind of learn to look at it like this. The left-hand limit graphically just means, you're interested at x equals 0. X equals 0 is right there. So as you close in from the left, the y value is -2. If you close in from the right, getting closer and closer to x equals 0, then what that is that's going to have a value of 2. Okay? So now the idea is the next one is a two-sided limit. So if you have a two-sided limit, and that's because it just says arrow 0, the two-sided limit, what you have is you have different things. So anytime the left and right are two values, and you're going in different directions on this, then we're going to say that this limit does not exist. Okay, and you can just abbreviate this as DNE on your homework that you're going to be doing on the computer. You can enter DNE anytime this happens. So that's the idea. Left and right limits don't always have to have the same value. They can have different values. And limits do not always exist. Sometimes they do not exist. Since the left and right are going to two places, they're not going to a specific number. And the answer to a limit is the specific number that y is getting close to as you're getting close to x. That's the idea. Okay, so in this next thing I want to do is I want to give you time to do a problem yourself. So I'm going to go down here, and one of the things I want you to do on here is use your calculator to kind of assist you with this. And I'm going to go ahead and pause the video like I typically do to give you a chance to work out a problem. Okay, so I'll pause now, and as soon as you're done with it, come back and see if you worked out the problem correctly. Okay, so moment of truth. Here's the answers that I would hope that you got on this. The idea, in a college algebra or pre-calculus class, you learn about quadratic functions. This is what we call a quadratic function. And quadratic functions have a graph that's a parabola. So your highest power is a second power. That's called a quadratic function. And the graph is known as a parabola on this. Okay, so again, on the graphing calculator, I just want to do this real quick. I'm not going to go through all the details of this. But if I put in x squared minus 4, graph that in the standard window, you're going to get this graph. And you can get these values by doing your table of values. If you go second graph, you can get as many good points as you want, like there's the point 2, 0, there's the point -2, 0, and so forth. So you graph your parabola. When you go through and trace these values out, the reason that I'm interested in this -1, and the reason I put blanks there, is because that's what we're looking for is the limit. These problems down below are asking for the limit as x is approaching -1. So when you traced these things out, these are the values that you should have got. And the idea with this is this first one here is a left-hand limit. And the left-hand limit just means you're coming from the left of -1. So as you get closer to -1 from the left, you should be able to see by these y values that they are getting close to -3. So that's why that happens the way it does. This next one was hold on, I did not do that right. I'm sorry, my apologies. Sometimes I put these things in a different order, and I guess I did that on purpose to see if you would catch that or not. Okay, so anyway, I explained it right though. So the idea is the left-hand limit is this one right here. Okay, so you're closing in on -3. And then the one with the superscript of a plus is a right-hand limit. So this one is going to mean you're coming from the right of -1. And again, you look at these y values, they're getting closer and closer and closer to -3. So what happened on this problem is the left and right were the same. So therefore, the two-sided is also going to be -3. So that's the idea. A real easy way to do this on a graphing calculator is, just after you do the graph, if you trace a number real close to 3, like if I put or not close to 3, I'm sorry, close to -1. So if I do something like -1.0001, that should tell you pretty well where this thing's approaching. So we're just getting closer and closer to -3. So you're tracing values closer and closer on the left and right hand side. That's the idea. Okay, so hopefully we did that okay. Now what I'm going to do on this is I'm doing this part 2 of this video in a couple of parts. So this will be the end of this video, and then I'm going to do the next part, which is talking about piecewise functions. So I hope you enjoyed the video and hope this gets you off to a good start with the idea of a limit. Good luck.